have a new project. This is our new project, and this is called Wailing Siren using only a 2 transistor, and it is composed of only a discrete components, capacitor, resistors. We have the power LED, the switch, and our output is this speaker, 4 ohms. I think this is 4 ohms speaker. Okay, so what is the supply voltage for this project? We're going to get the supply from our workbench power supply, about around 12 volts, and this type of switch, this is a lat switch or a toggle switch, just like a switch in our for every house or in our home. A lat switch. Let us now supply the voltage around. What if we have 5 volts supply? So we have now the power LED. Okay, power LED turns on, and then if we press the switch, we got a reading in ampere and also our wattage rating here. How about 12 volts? 12 volts. We are having 75 milliampere of current. $75 milliampere. .9 watt of power. Again, by using 12 volts, there is a stray sounds. We can hear a stray sounds here. Using 12 volts, it has a high frequency to the output of to the output speaker. What if we're going to use just 5 volts? A much lower frequency is going to be heard. Small current, small wattage rating with a low frequency, sound frequency of the speaker. Using 5 volts, we are having a low frequency sound, and 12 volts, we can hear a high frequency, about 9 volts. As you can hear, This type of siren is called the wailing police siren. Now we have the police siren using transistor schematic diagram. We're using 12 volts supply with power LED blue 4.7K current limiting resistor to the power LED. And then we have two transistors. Two transistor. One is PNP type 557 and NPN type 547. With a resistor, switch, and capacitor, and also the speaker. So what is the workings of the circuit? How did this becomes a police siren? How will it how can the speaker works, or how will the speaker works? So for this circuit, this is an oscillator. There is an oscillator. This circuit is a type of oscillator. So let us connect the oscilloscope to the speaker to see the oscillations or the frequency of the circuit. Let us now check the circuit. We have the oscilloscope connected to the circuit. This is the oscilloscope, and then also the power supply. Let us now supply the circuit with around 12 volts. Push the button. So this is now the waveform generated by the circuit. We have this oscillation, a waveform. Looks like we have overshoot negative voltage. And then for the frequency, using the A and B mode, X and Y. So we have a frequency of 885, or oh yeah, that is the frequency, 885.1 Hertz. And then this one is the period. From here to the other uprising waveform. This is the waveform. So we made a snapshot. A snapshot for the waveform. Now we have the oscillation. Looks like this. The output waveform. It continues to oscillate. So how does this circuit works? When we have this circuit, the speaker will we may hear the police siren whenever there is a current that flows into the speaker. It is only possible when this transistor turns on. If there's a base voltage or base current here, to turn on this transistor, and then to turn on this transistor, there's a base emitter to base. To turn this transistor, we need a current here and then the current here. Since initially there's no current that flows into the transistor and then to the speaker, we will not hear the police siren because the switch, which is the last switch, is open. When we close the switch, it will charge the capacitor through 47K, then discharge through R2 10K, then to the R3 1K, to the speaker, and current flows also into the emitter to the base of this transistor, and then to the collector to emitter, then to the ground. So there's a base current here. There is a tendency a current will also flow into the emitter to collector of this transistor. And also the current flows from R3 to the collector to the capacitor, causing this speaker to generate a sound frequency due to the continuous charging, discharging of the circuit, charge again, discharge, and once we release the switch, the only power we have is from the capacitor, so it will make the sound to fade, or fading the sound, or slowly turning off the sound, because since when we release the switch, this one now is act as the supply to the circuit. It will now discharge to this capacitor transistor, causing it to turn on, then also here, until it eventually we don't have now the sounds, because the capacitor will fully discharge once we release the switch. So it will just serve as the power to the whole circuit. But when we press it again, it will continue to sound the speaker oscillating, creating this waveform. When you release the switch, it will now slowly fading out the sounds, because this capacitor will serve now as the power supply to the whole circuit, causing this transistor to turn on this transistor to make this speaker, the sound to fade out, fading out the sound until it slowly fading out the sound.